Welcome back. So we were just finishing up with learning about how Robert Koch identified specific microbes as causative agent for specific diseases. And this led us to immunological studies. So now we know that specific pathogens cause specific diseases. Now we can start trying to figure out how we can treat those diseases. If we know what's causing it, maybe we can treat it. And so this leads us to Edward Jenner. Edward Jenner actually predates these individuals, Koch, Pasteur, well, not Pasteur, Koch, Lister, and Agostino Bassi. He does predate Pasteur as well, but I didn't talk about him in the medical microbiology. So Edward Jenner, in the late 1700s, he actually produced one of the first forms of protection against a disease. So most people call it a vaccination. It was actually called a variolation procedure. And this preceded work that determined that microbes actually cause disease. And so let's see what he did. So here's Edward Jenner. He is thought of as the father of immunology. And what he actually did was he took scrapings from cowpox lesions to protect people from smallpox. And people that were infected with cowpox were then immune to smallpox. So where did he come up with this idea? Well, he was a scientist and doctor, and he was studying smallpox, and he noticed that milkmaids never got smallpox, but they got this other disease known as cowpox. And he hypothesized that maybe if you have cowpox, you somehow are immune to smallpox because they never got sick. Well, this is at a time where people didn't always have a lot of money, and so families would give their children to respected doctors and so physicians and scientists to be their workers. So they would basically be an assistant, and they would learn, or apprentice, and they would learn from these scientists or doctors, and then they would have a better life because not everyone had the money to send their children off to school, so they had that on-the-job training. This is what happened actually in the case of Edward Jenner. Edward Jenner worked with a young boy, or had an apprentice, James Phipps, who was an 8-year-old boy, and Edward took James and decided to run an experiment on him. So he cut James's arm, and then he filled his arm with materials from scrapings from cowpox lesions. And James then proceeded to get sick with cowpox, which is a mild disease. And after a couple of weeks, he was better. And then Edward said, okay, now we're going to test my hypothesis. I think that now that you've had a cowpox, you will be protected from smallpox. So let's test this. So he took scrapings from a smallpox patient, and he again infected James Phipps with the idea that he thought James would survive and not get sick. Now, he could have been wrong, but if he was wrong, then James would have died, and Edward Jenner would have then kept going on his work. Very unethical today, but back then, not so much. It was just the way life was. James did not get sick. In fact, he stayed healthy, and Edward and James had a great relationship, and James is not famous for anything, but we tend to remind people of his importance in establishing this cowpox, smallpox interrelationship. And so this is what cowpox looks like. It's a very mild disease, and it goes away after about a couple of weeks. This is what smallpox looks like. So smallpox is not only deadly. People who get smallpox oftentimes will die, but if they don't die, they are disfigured. So these pustules leave scars, and smallpox is opposite of chickenpox in how it develops. So with chickenpox, if you've ever had it, you know that it develops first on the torso and then it moves to the appendages and the face. With smallpox, it starts on the face and appendages and then moves to the torso. So your face, arms, and hands, legs are going to be scarred for life. So now we know that there's such a thing as a vaccination that we can use, or a mechanism for treating these diseases. So in the late 1800s, Pasteur and Raux actually produced the first attenuated vaccine. And they did it by accident. It was kind of a fun story. So they were trying to come up with a mechanism to protect chickens from a bacterial disease, cholera. But every time they were injecting chickens with the cholera bacteria, the small amounts, medium amounts, whatever, chickens kept dying. Well, then they ended up leaving their work for about a week and left their samples in the incubator. When they came back, they picked up right where they were working previously. They took the samples from the incubator that were now over a week old, and they injected small amounts again into different chickens with the idea of hoping that the chickens would produce an immune response and be safe, or be protected from the disease. And when he injected the chickens, they didn't get sick. And he thought, okay. So then he said, well, maybe, these samples are bad. So he got some fresh samples and he injected the chickens with the fresh samples to see if they could, produce that immune response. Well, the chickens again did not get sick. And he thought, well, that's weird. So then he inoculated other chickens that, with the same new sample. And those chickens got sick, but they died. And he thought, well, this is just weird. So he went back to his old samples and he started running some experiments and realized that when you take old samples, these samples are no longer able to cause disease. And he called them attenuated cultures. Basically, they're inactive, they're unable to produce the disease. And then he named the attenuated cultures a vaccine. This was in honor of Edward Jenner, who had produced that cure for smallpox. Vaccine, actually, the term vaccine, vaca, means cow, so it was kind of an honor for Edward Jenner. I'm going to stop here and we'll get into the next part of the chapter in a little bit. Bye.